everyone, my name is Matthew Emmerich, and I want to help you get into the field of artificial intelligence. It's a huge field. There are a lot of ways to approach it, and we will try to cover on the majority of those. And it doesn't matter if you're starting earlier in your career, later in your career, you're about to retire. If you're interested in something, go for it. You can do it. All right, let us begin. So, where do you start? That is the first problem that you will have, that I had, that everybody has. And where can you go? What career choices are there? I assume that you're not going to choose AI as a hobby, though you could. I applaud you for it. Maybe you want to go into research. Maybe you want to work for some corporation. There are so many paths. Every path is unique anyway. Your path will be different from everybody else's. Your journey is different. And I'm just here to help you with some basic advice. And the first piece is the question of whether college is the right choice for you if you either plan to go back or are just starting out. And if you do go, what majors and minors are there at the undergraduate level? Do you need to go to graduate school? And what other methods are there if you choose not to go to university? What overall skills are required, both hard technical skills and soft human skills? Which ones are the most helpful? Do you need to build a portfolio? We'll touch on this a lot later on. What projects will help you the most? How do you organize them? How do you network to find good opportunities? It helps if you know people. It gets your foot in the door. It can give you so many opportunities. Highly recommended. How do you stand out in order to get hired into the field? Because even though there aren't enough people to fill the AI roles or data science roles that exist, it's still hard to stand out. It honestly is. So I'm hoping to help you with that and to give you some basic advice. So you're starting out. You're either going to university for the first time, you're going back, you're just changing careers. It can be kind of scary. But you're going to feel the fear no matter what you do, so you may as well just do it. Just do it. You can do it. Start with research. Start with the end in mind. Where are you going to go? Where are you right now? Now, there are two major feelings when changing the field like this. Either I'm an imposter, I can't do it, or I already know everything. These are two ends of the spectrum. You're somewhere in the middle. You'll go back and forth. You're not an imposter. You can learn whatever you need to learn. Anybody can learn any skill. You're not an expert. I don't care what courses you've taken. Have you created a true AI, some AGI program? Then you're not an AI expert. You may be an expert in some technique or another. Probably not. But you're not an expert. Now, do you generalize or do you specialize? This is very difficult to go back and forth with because generals have the most fun. Specialists are the ones usually seen best for most roles. So what are some examples? Maybe you like computer vision. Specialize in computer vision then. If you like language and linguistics, focus on natural language processing. If you maybe have a biology background, genetic algorithms. You are at least starting somewhere. Focus on what you want to do, where you want to go, and if you want to specialize. If you are a generalist, your path is a little bit harder. It can be a lot more rewarding. You can jump back and forth. You can think of solutions that specialists cannot. But it's a lot more work. That's the same boat I'm in. The key for anything with AI or any field this complex is to never stop learning. It's very important. The field changes every day. You need to change with it or you'll be left behind. Know the latest techniques. Know who's who. Keep up learning new skills. Learn something every week, every month, something. and keep up your network as well. You never know what the future will bring, as we've seen in the past year and a half. So, starting with the end in mind, one of the biggest things you hear about in AI is a data engineer or a machine learning engineer or a more general AI engineer. These are the plumbers. These are the electricians. These are the ones who do the infrastructure for an AI project. For instance, a data engineer will build the pipelines that the data scientist will later use. The machine learning engineer will build the machine learning pipelines. So it's all about data pipelines. Honestly, it's the same for all three. They are just different titles reflecting the exact same role. Maybe you want to specialize. Maybe you want to be more than just the plumber. You could be a natural language processing engineer or developer. Same difference. Here's where you focus on audio input and matching words, matching intent, analyzing the emotion, summarizing data, or you are more interested in vision. So computer vision engineer or developer, you focus on graphical or video input. You do object segmentation. You do a lot of different things. It's not just machine learning, though that is a core component with both of these specialties. Maybe you want to take a step back and focus on the business side. So you might be a business intelligence developer or analyst. That's great too. There's a lot of data out there that's not just audio, it's not just linguistic, it's not just visual. It's a lot of data. There's so much data created every single day. A great entry point is to become a data analyst. This gives you a lot of experience working with data overall. You look at patterns in the data. You learn how to present your findings. It's a great stepping stone into an AI field, a more technical AI field. Maybe you want more of the hardware side of things, though. I'm sure you've heard of robots before. Most people have. And a lot of people have either an overly negative mind about them, thanks to movies like Terminator. And some people have a more positive, thanks to movies like Short Circuit or other works of fiction. But robots are a huge physical component to AI, and they always will be. And this is a great way to get into it as a robotics engineer. Maybe you want to go into the actual edge of the field. Research is your best bet. This can be at a university, it can be at a corporation. You have a lot of options here. This usually does require the PhD. It's a lot more work to get into, a lot more effort, a lot more time, higher cost, but it can pay dividends. If this is your field and you're just starting out early, this is a great way to really dig deep. You're still marketable to businesses, but you super specialize typically. So be very careful about that. There is the sexiest job of the 21st century, the data scientist. This is when you care more about the data. It's usually more the business side as well. So a data analyst may become a data scientist later on with more experience. And it's not a real AI focused field, but it is an option if that's the way that you end up wanting to go. Now, not every career that is AI related has been invented yet. One up and coming role is the AI Ethicist. This is more of a philosopher type of role. You take a lot of ethics courses, you apply it to AI. It's great for the legal field. I read about a legal firm that focuses only on AI law. Good for them. There'll be more of this. There'll be a lot more once self-driving cars become more mainstream, if they ever get to that point anytime soon, and they start running people over or causing property damage or get their driver killed, because it's going to happen. It is going to happen whether we like it or not, and legal firms will step in whether we like it or not. So that is one option. There are technical writing options specifically for AI. So you could dive deep into the field overall and work on your writing skills also. You have a lot of options. If you really want to have an easier time figuring things out with this field, figure out what you want to do and just go for it. So, university. Should you go? Should you not go? If you do not have a bachelor's degree, you should go get your bachelor's degree. It opens more doors than anything else will. You technically can go to boot camps, but a lot of roles once you have the bachelor's degree. You better have a strong portfolio, a strong network, and you better hustle if you do not have the bachelor's degree and do not want to get one. We'll talk more about undergrad level work later on. But if you're coming from a completely different field, let's say you are an accountant, you're great at math, which is a very important skill for AI, but you are underwhelmed by accounting. You're adding up numbers all the time. You're looking for missing money. You're doing this, you're doing that, but you want something different. AI is a good field, and you will probably want to go back to your university, add on a minor, maybe in computer science. It's an option. If you're coming from the humanities and you want to work a more technical role, you can get away with not going to university. It's easier if you do go back, earn a major or minor, or multiple. You don't have to. If you want to solidify your foundation. Now, I have minors in philosophy and psychology, majors in cognitive science and computer science, and a master's in computer science. I'm already looking at going back to get my second master's degree, this time in artificial intelligence, but I would also benefit from a stronger mathematical foundation. Redoing my calculus, redoing my linear algebra, taking more stats courses, that would be a huge benefit to me personally. Maybe it is to you as well. A lot of people take the minimum amount of math, and that's not always the best bet for you. Or maybe you just want to go back. That's part of the reason why I'm looking at my second master's degree. It opens up doors, but if I could, I would be a professional student, and I would love to just keep taking courses and collecting more and more degrees. I'm kind of weird like that. Now, when doesn't university make sense? If you already have an undergraduate degree or a master's degree, it makes a lot less sense. Most people who earn a second master's are earning something like an MBA, so they can move up within their domain of interest. Like I said earlier, I'm going back because I want to. Now, if you already have a good foundation, you have a math minor and a computer science major or minor, you've taken all these courses, you are a good developer. You are doing these boot camps and building up a portfolio and networking and such. You don't need to go back. So save your time, save your money, save your effort, and focus on things that make a lot more sense for you personally. If you're coming from a related field, software engineers, you probably don't need to go back to earn another degree. You can learn a lot of things on your own, even the math if you really want to. But university probably does not make all that much sense. Now, what are the majors and the minors? The most important one is computer science. You need to be able to program, even if you're not looking at AI from a technical point of view, which you don't have to. Mathematics is great as well, more for a minor, but if you go into research, a math major can be a huge benefit. Statistics is big right now thanks to machine learning because it's all statistical programming when you get down to it. Psychology. If you want to go deeper into the field, a psychology minor where you choose which courses, such as developmental psych, neuroanatomy, cognitive neuroscience, things like that, things I've taken each and every one of those, then that can be very helpful. Philosophy, I left off this list, but it's in the same category. It's more about ethics. It's more about logic, which is important. Theory of knowledge, theory of mind. All helpful courses. You can take them without doing a major or minor. Major is kind of overkill for the most part. Cognitive science. That combines computer science, psychology, and philosophy. You can take linguistics courses as well and count those, typically, depending on the university. It's a great major to pair with a computer science major. And you can still earn minors in philosophy and psychology at the same time. That's what I did. Electrical engineering, if you're going to go into robotics, that is a great option and kind of necessary as well. Data science. There are more degrees in data science offered these days than there used to be. Great option if you want to focus on the data science side of things or the business side of things. And finally, AI as a major or a minor, typically a major for now. We're seeing more and more of this. Same at the graduate level, but this usually covers everything. It usually is very technical focused. So some cognitive science on top of the AI would be a huge way to round yourself out. If you want to focus more on the technical, this is a great way to go, but it's a lot like a computer science degree with a bit more math and just very focused electives. Up to you. Now, at the graduate level, should you go back and get a master's degree? If you want higher level positions, ones that pay more, you probably do. It also deepens your understanding of the field, which is very important. Unfortunately, a lot of these degrees focus on the technical above anything else. It won't focus on AI ethics. It may not focus on how human intelligence works, unless you take extra courses, which means more time, more effort on your part, but it can open up a lot of more opportunities. It's kind of necessary for AI research, probably all the way up to the PhD level, or for leadership, as I mentioned earlier. It also opens up a huge networking opportunity with your classmates, with your professors, and with businesses that work with the university. Something to keep in mind. Now, if you do not go to university or you already have, I would recommend earning a certification. There are some very common ones out there that are free. There are ones that cost money as well. And for these, much of any learning opportunity, you get what you put into them. You can do independent projects. We'll talk about that when we get to portfolios a lot more. You can write articles, start your own blog, create your own YouTube channel, and create videos. Reading and reviewing books. I've been doing a lot of this. Reading books, of course, you kind of need to if you want to pick up some new technologies or new perspectives. And reviewing books is a great way to get your name out there and to network with the authors and with the publishers of these books. And then a lot of the readers will see more of your work as well. Now, onto skills. Technical skills. You need to be able to program. Even if you approach things from a psychology point of view, you need to be able to build something. AI is hands-on. Math and stats are fundamental to AI. It's artificial intelligence. So anything with engineering or computers needs at least the basic math background of calculus, linear algebra, and stats. You need to know the basics of machine learning because that is the focus right now. And it will be for quite some time because that's what businesses are doing. That's what they're putting their money into. A lot of that can be solved by regression. At some universities, you can take entire courses on regression. You can find books on regression. I highly recommend to work on your skills because a lot of machine learning problems are reducible down to a regression algorithm. Human skills, communication. Can you talk to people and explain what you're doing? Can you write about your project so if someone reads it, they'll understand what's going on and why? Very, very important. You will almost certainly work with a team. Can you work with other people? That's kind of necessary. Leadership. Can you lead the team? Can you step in and lead the team if your leader is out sick or on parental leave? Can you lead the way to solving the problems? Which leads us, of course, into problem solving, which is a huge thing. Because if you're not solving problems, you're probably causing them, and it's not going to look too good for you in any field. Ethics is another huge area right now. It's picking up a lot of steam in the AI area, and I highly recommend that you have a basic understanding. And now, there's no magic bullet, but the closest thing we have in the field is building a strong portfolio. So, showcase that you can actually do the hands-on work. Can you create something from beginning to end? Can you document it? Can you talk about it? It's proof that you can do the work. And I definitely recommend having a variety of projects. If you are focused in a specialty, do a bunch of those projects, but do a few things outside as well, just to show that you can, because you'll still be doing things with other specialties or working with people. Use a versioning system such as Git to allow people to go back and look and see what you changed, how you started it out, how you built it in the first place. Document everything. Keep a complete paper trail, all the changes that you make with each new version. Write tutorials, write videos of how you are doing it, but definitely have a write-up for each and every project. And you want to really network with this. If you're on LinkedIn, which I highly recommend, feel free to look me up on there. You can write about the projects that you're working on. You can post videos, which you really should be doing to have demos of where you are right now. People will chime in, give you advice, but you also have the naysayers, ignore them. Do not do toy projects. If you go through a course or a book, they will give you the code for a toy project. You throw it together. That's not what goes into your portfolio. Your portfolio should be your work. And I highly recommend that you use real world data sets. There's so much up there. Data.gov. Google has a complete search engine just for data sets. Look that one up. There are just so many out there. Don't stick with the MNEST set of handwritten digits. Don't do the housing data stuff or the Titanic survivor stuff. Go deeper. There's so much out there. So common projects that you might want to think about. This is great if you are a generalist. So do maybe one from each of these groups. Doesn't have to be all that big. So do some machine learning. I would try out different algorithms for the same problem. Obviously, it won't be supervised for one and unsupervised for the other, as they have different goals. Do something with natural language processing. So analyze text. Text is everywhere. Vision. You have a webcam probably. It's probably built into a laptop. You can record video on your phone and upload it. You have a lot of options there. Build a robot. It doesn't have to be big. I would recommend doing this one from a book, but actually running through it and building it. There are a lot of options out there. There are a lot of websites with programs, and they do a better job than the books for giving you an outline of the cost. Do something with distributed AI. So can you do anything with networking? In our very connected world, you will need to show that you can handle this. Build a GUI. You need to show that you can interact with people. So people need to be able to control what they're saying and what they're doing. Learn the common libraries, and I don't think I have a slide for that, but I'm thinking scikit-learn, learn TensorFlow, learn Keras, learn just pandas, definitely pandas. Look them up, do the basics, find some great resources. There are a lot of free resources, but learn the basics of using them. You will not go wrong with that. Now, you need to be able to network. This is difficult for a lot of us because technical fields really bring in the introverts. Not all of us. And you're not a complete introvert or extrovert. You're in the middle somewhere, but you need to be able to put yourself out there. And LinkedIn is the number one way still to do that. It's a great way to meet new people, to get invited to talks and courses. I've been asked to speak once or twice as well, including here, thanks to LinkedIn. So definitely a thumbs up for jumping onto the platform. You should be following people that you know, following the major voices in the field, and you should leave thoughtful comments and congratulations and so on their posts. That will make them interact with you and occasionally to direct connect with you, which opens a lot more doors to a lot more people. Okay, so go to webinars, go to talks, go to conferences, ask questions, and connect with your fellow attendees. That's very important. I've done that a lot. I met a lot of great people there. Posts, you need to make your own posts as well. It should be about what you're working on, any courses that you're taking, any thoughts you have about AI. Maybe it's a response to someone else's, so you share their post and you comment on it, but add something to the conversation as much as you can. And definitely respond to comments on your post. Now, you have to stand up. If people don't notice you, you are not going to get any offers for positions, for any opportunities, and that's kind of what you want with AI. It's still a tough field, and everything that you do should be working toward your career goal. You get your name out there, interact with people in your field so that they recognize your name. And your hands-on stuff, your portfolio, that is key to anything with AI at this point in time. Get it out there. Get your hands-on work out there in front of other people, whether it's version 0.01 beta, get it out there. Learn about related areas. I'm huge on the cognitive science side as well as computer science side. And I talk about data ethics and AI ethics a lot on LinkedIn. And above all else, always be professional. There are a lot of people, even on LinkedIn, that just mess it up for a lot of other people by being rude. They are very, very sloppy. Watch your grammar, of course. But be a decent human being. Some people still have issues with that. And those are not people that get the opportunities, that meet the people that will open up doors for them. So let's finish up. You are capable of learning AI. Anybody is, but you actually want to do it. You've got this. I don't care where you are in your career. I don't care if you are 70 years old. You can learn AI and you can have fun with it. Even if it's only a hobby at that point. Have fun with it. I highly recommend having a goal in mind. Know where you want to go. Know how to get there from where you currently are. That is your path. It's different from every other path. That's why my advice is so general. If you want to talk to me about your specific path, feel free, but this is your path and you are responsible for it. Have a foundation. The best analogy I have for your foundation is that you have a platform and you have grains of sand of what you're learning. Eventually, that will fill up and anything else you learn will just fall to the sides. The bigger the platform, the more sand you have on your foundation, and the bigger things you can build, the more you can do, the deeper you can go. Know the main skills. So your technical skills, your soft skills, be able to talk to people about what you're doing and write about it. And I highly recommend finding a mentor. Find someone to talk to. You can change mentors as needed, but find one who works for you at your current stage. They can help introduce you to other people. They can help you find opportunities, and they can help keep you on the path. I wish you the very best, and I hope to hear from you soon and see you in the field. Thank you.
Hello, my name is Rob Cheek. I'm the Emerging Technologies Analyst at Hyundai Motor Securities, the investment banking arm of the Hyundai Motors Group. And today I'm going to talk about investing in robotics for massive ROE. So, a little bit about myself. As I mentioned, I am the Emerging Technologies Analyst at the Hyundai Motor Securities, and under that purview, I'm also the Senior Robotics Analyst. I served as a Director of Innovation and Business Development at Eugene Robotics and was the co-creator of Go-Kart, one of the world's first SLAM-based commercial AMRs, autonomous mobile robot. I am a Senior Advisor at aerial robotics company Uvify. I serve as an advisor to several stealth robotics companies, and I am a consultant to several Fortune 500 companies as well. So, investing in robotics for massive return on equity. So, no or ROI, yes, so RE, what gives? So, we all know that ROI is the standard definition of return on investment, and what you generally look for when making an investment decision. We submit, however, that ROE, while typically used as a metric for return on equity, which is the gain that a company makes from stock, is more apt as the term to measure business decisions made with robotics. We think about ROE as the robotics of everything. That is, where robotics technologies are developed and deployed to impact everything. If not now, then eventually. In other words, is it in the realm of robotization? Peter Diamandis said the acceleration and convergence of exponential technologies will completely reshape every industry and society over the next decade. The key for robotics companies and their investors in robotics is to leverage this concept to build robotics technologies and solutions that will serve as the pieces in this puzzle. So, the question is, why are we all here? Obviously, we're here to improve the visibility into the robotics business and technology ecosystem. We may be a robotics company looking for growth, an investor looking for robotics companies with growth potential, or business looking to grow and optimize with robotics. Whatever it may be, we have a shared goal, and it's to realize outsized gains via robotics. And some of us may be students. So I like to say the highway to robot hell is populated with zombies. So much like The Walking Dead, or like zombies, they eat brains and funding and time to no good end. They use public and private funding support. They have a blurred vision of the market. These are useless robots. They suffer from engineering myopia. They neither excite, nor satisfy, nor solve anything. Basically, these are robots for the sake of robots. And this is no longer viable. As you all know, the promise of robotics has undelivered or underdelivered in terms of return on investment. Many know most robotics companies, or most companies in this space, are completely useless, and as such need to be put down. However, this is coming to an end, and very quickly, and because we've seen more than our share of robots that fail to deliver to their customers or to the investors, which place their faith in these companies. So investors and the market are losing their appetite, as I mentioned, for these pie-in-the-sky robots. The pandemic has only exacerbated the situation with the shuttering of more companies. The spate of failures since 2017 has diminished investor appetite, and ultimately robots must do more than simply be interesting. They need to have a competitive edge in what they're doing, or they need to define a new category. From the silly to the nearly feasible, losses with many of these companies continue to mount. However, in contrast, gains are being made by those that provide the edge, as mentioned above. a belief that technology in and of itself is a sustainable, viable investment is misguided. Again, the promise of many robotics companies have under-delivered in terms of return on investment. And as Kevin O'Leary says, these companies really need to be taken out back and shot. The problem with many of these robotics companies are what I call the underpants gnomes business model from South Park. You approach the market with a product and then expect the market to buy in. They skip the critical middle of how they're going to achieve profit. Therein lies the key to failure. So, really, when we look at the perspectives between the founder and the investor, what the founder sees is here on the upper left, and what the investor or market sees of some robotics companies is on the lower right. Design is not an afterthought. We know this thanks to the work which done at Apple, which took a company that had average or often below average technology in terms of specification to the world's largest company and brand. Done largely with power of narrative and design, built on the technology. If you took a company like DJI, which clearly wants to be the Apple of aerial robotics, you can see that it's following the form or recipe that Apple created design-wise. But what DJI is really missing is the key ingredient, and that is one of the key ingredients, and that's narrative. So neither narrative nor design is an afterthought. And despite the stream of failed social robots, tech industry veterans continue to push the narrative of why their robot is different or how they will make money and build the next awesome thing. This is irresponsible and a waste of precious resources, money, talent, and most precious of all, time. But the market is not ready for a social robot just for the sake of a social robot. There is no need for something that can be done with a roboticized system, vacuum, cleaner, car, all of which are being imbued with social capabilities. And go into the presentation, some of the major errors by robotics companies are one, complexity must be translated to narrative that everyone understands, creating a narrative that inspires and influences. And if you don't have a story, you probably don't have a business. I like to call these "don't build me too D2s." So like the Apple Newton, these concepts were derived from social robot failures, and they will eventually pave the way to economically feasible social robotization applications and eventually viable social robots. And there are valuable lessons learned when when the time is ready, and we will apply the lessons into viable products. Current thinking in social robotics and HRI focus on the robot and how it interacts with humans. And the talk even extends to issues such as robot rights, robot citizenship, and other meaningless issues, in my opinion. But my view on the current state of social robotic products certainly does not discount the value, present and future, of HRI and social robotics. It is imperative to designing robotics products and services which are in everything. For if we do not have systems which are able to interact with us humans in meaningful ways, it will certainly prove a commercial liability or risk. So, in short, the current paradigm of social robotics is broken, the way it's being thought about. And as such, the reasons why most social robotics companies will go bust. These academic enterprise social robotic failures, ventures are recipes for failures. One, the social in social robotics is overly robot-centric, not robotics-centric. Social robot product releases, despite persistent failures, drive the sector forward, and HRI must focus on interacting with roboticized systems. So, social elements within products. So, for example, a car. I think Elon Musk said Tesla is arguably the largest robotics company in the world because of their automobiles. And so they think about the social element within the cars. And really, when we think about this, there's a lot of truth to that, and the thinking about roboticized systems, that's where we really need to apply the lessons learned from social robotics research. So, I'd like to talk about computerization versus robotization. They're the same, but they're different. So, products went from products, mainframe, to computers, to mini, industrial computers versus PCs and embedded computers, which are in everything. The users, there were governments and large corporations versus today SMEs and consumers, business models, purchasing, where today we're moving to service, software as a service, robots as a service, deployment, large to small to ubiquity, and convergence, computerization versus robotization. What do I mean by that? When we look at computerization, you can think about, if you would ask your grandparents about a computer, well, it's this thing in this room, or maybe it's this thing that sits on a desk, rather than their embedded computers that exist in everything around us. They're ubiquitous. In much the same way, robotization is following a similar trajectory where we are seeing robotics technologies being embedded, becoming a part of everything. Again, going back to the car or a cart, or you name it. There are ways that robotics are being imbued into existing products and used to create new products, which we shall see on the market in the near future. While they do share a similar, if not the same trajectory, robotics may take slightly longer due to the complexity of cyber-physical systems versus straight digital systems, and the inherent complexity of robotics, relative to just computing. So really, we need to redefine what a robot is, or what it means to put ourselves in the mindset to realize massive gains from robotics. So we have to break away from the traditional paradigm of robots and think in terms of robotization, and develop products and businesses with robotization as the central theme. So you ask yourself, do you have a business or do you have a product? In the robotics business, there are so many companies that launch or secure funding, but in the end, they have a proof of concept. Maybe they have a product. So if you plan to invest in robotics companies, or build a robot and you expect to generate massive returns, the focus should be first on business. And so you must identify and address this issue. And it's incredibly important that you make this distinction, and that you do so early on. Your early decisions, your business model, your long-term trajectory, costs and workload will vary drastically depending on the path that you choose. Making the right decision will mean the difference between a windfall of profit and a complete mess. If you're building consumer robots, then it is imperative to realize that you are, in at least the near term, building a product, not a platform. Even the iPhone and many other devices, which are held up as the model for many companies, developed their own applications to support their product in the beginning. If you have built a proof of concept, then ask yourself if it is viable before you launch or you invest in it as a business. So these are examples of, these are neither product nor business nor service. I call these pictures of waste. Laundry folding robot, which cost, I don't know, $10,000 when it was released. Megabots, which were supposed to entertain people. Not ready yet, and not the time. And this abomination on the right, waste of resources. Unneeded, uncompetitive, and unsustainable investment. So Zoom, the infamous pizza robot, delivery robot pizza company that burned through $100 million, and the food was not good. It had robotic arms inside. The idea was to eventually have the truck be self-driving, and that the pizzas would be made en route to the customer, to the delivery point. An abysmal failure, and the Juicero, which was an app-enabled juicer. Tech hubris, nothing more than tech hubris. And so again, do you have a business or do you have a product? And if you don't know, this is what you're going to end up with. So make the right decision when building a robot or investing in robotics. So, there are three sides in the business of new robotics companies and technologies, in my view. I call this conjoined triangle of robotics. It's crucial that they are in alignment for the business of robotics to succeed, or your investments to succeed. They are interdependent. While robotics companies generally come up with an idea, it is imperative that they survey and understand the market in which they serve, and they should not attempt to force their vision of what the market wants. However, there are exceptions where this has worked, but this is rare. And in the business game, you better be playing with the odds in your favor. The robotics market and customer can be understood by studying people. Trends, behaviors. It's not rocket science, but simply taking the time to look around at what people are doing, what they're asking for in order to determine how to build a better proverbial mousetrap. The investors and advisors are crucial to the process because they bring experience and domain knowledge which extends beyond the realm of robotics companies and their founders. So the operative word for achieving amazing results from robotics is ubiquity. Your robotics technology should be deployable to as many applications as possible with the shortest distance from launch to use. And we'll have a look at a few examples of success cases and explore how to make this happen, or how you can find these. For investors to realize outsized gains in robotics, they must identify and invest in companies with robotics technologies that can be applied to more than a use case. One need only look at the poster child of great robotics investments, which would be Teradyne, their acquisition of Universal Robots, Mobile Industrial Robots, and AutoGuide, all of which serve multiple verticals and which are being used to create new use cases, new products. And this has proven very profitable for the investors in Teradyne, as well as for Teradyne. And I expect this Teradyne and their investors to see outsized gains in the years ahead. On the other side of that, we can look at something like the Jibo, which was a spectacular failure and a completely useless product. And I'm remiss to even use the word product, because I guess we could call it product. So massive connections mean massive returns. The era of convergence demands a rethink of business and product design. Telephone is a perfect example of the network effect and connections. In robotics, I think companies like Berkshire Grey, which has a complete end-to-end solution for 3PL, warehousing, several other use cases. There are massive applications as only 5% of warehouses are automated, and there are far more areas where this technology will need to be deployed. And Berkshire Grey has an end-to-end solution which should prove very, very attractive for investors and Berkshire Grey's customers. I think Titan Medical is interesting. So is Vicarious Surgical. Titan Medical, because they're offering what will be a lower cost version of the very successful Da Vinci surgical robot, and there is a tremendous need for these types of robots in more healthcare facilities around the world. And I think Titan Medical, with a partnership with Medtronic, will help to create more applications for these robots, generating massive returns for the investors. Kratos, who's building very interesting aerial robots to augment the U.S. Air Force, just to basically force multiplier drones, if you would. I mentioned Teradyne mobile robots earlier. I think Ouster is very interesting. Ouster LiDAR, they're unlike other robot sensor companies, the LiDAR companies that almost exclusively focus on self-driving cars. Ouster has a focus on that, but they also serve aerial robotics companies, smart cities, drones, aerial robots, mobile robots. So again, the potential return for Ouster as a company and for investors are potentially massive. And of course, while industrial sales still remain important, and of course they're on the rise, the game is changing, and again, the era of mass customization is on us, and with mass customization, we need more flexibility, and that flexibility can be provided by such robots as those offered by Universal Robot or Teradyne, which already has a tremendous user base that's growing. Your competitor may not be a robot, so if you are building a robot or investing in robotics, keep in mind that there may be a solution, or there is likely a solution that is either better or cheaper or both. So it's imperative that robotics companies and investors examine the competitive landscape to see if there's an existing or superior technology solution which can do fulfill the gap that you believe that the robot is fulfilling. So of course, this is just a chart on the world spending on robotic systems. I would argue that this number is rather conservative, not touch on that too much. Global automation market, I think one of the biggest growth areas, massive returns, is going to be the warehousing market, and we see that by all the acquisitions that have been taking place. Again, Teradyne appears to be the leader in this space, but we see Zebra acquiring Fetch. We've had a few other. KUKA acquired a company called Asti. We had a recent IPO, or rather not the IPO, the listing of Berkshire Grey, which is a pure play 3PL warehouse robotics company. Drones. Of course, the pandemic has accelerated the evolution of robotics. It also saw the death of many robotics companies, Starsky, Airware, Carex. Robots really must be of more use and do more. If you want a friend, rescue a cat or a dog. So evolution accelerated is going to really come in the form of innovation plus commercialization. I think teleexistence is very interesting. Like this robot, the Model T. They had a robot called the Model H. Again, robot for the sake of robot. It was, walk around and look at stuff. But the Model T shelf stacking robot is very interesting. With this robot, businesses in Japan, particularly convenience stores, are addressing the labor shortages and rising labor costs by using these robots to have lower cost labor from other countries work to stack shelves at their stores in Japan, and while at the same time training these robots so that they will eventually be autonomous. So it's a visible path to growth. It's practical, it solves labor shortage, provides access to lower cost labor globally, viable path to growth, using humans to train a robot for full autonomy, solves an immediate problem, raises social distancing or increases it, and lowers operation costs. So the top 5 industry with robotization potential is agricultural, food services, health, medicine, law enforcement, manufacturing, and transportation. So I like to talk about zigging, fear of missing out. FOMO drives the zig mindset in many companies and investors. So everyone's doing this, I got to do it too. And so it's not good for the company, nor is it good for investors because you don't generate outsized returns. In fact, you may generate an outsized or realize an outsized loss as a company or as an investor by following this path. So zigging one, there's a world of a red ocean of ultraviolet robots. Everyone wants to put a light on top of a mobile robot. It's just flooded, and most of these companies will fail. So the companies will go under, and investors and their employees will lose. And also with professional cleaning robots, this is also turning into a giant mess. Many of these companies are dependent on a couple of companies for their technology, and majority do not have any understanding or focus on multi-robot systems, and so they'll be mocked up by those with a better view of how to deploy those multi-robot systems. More zigging, skies are polluted with drones chasing the same targets. It's just the same stuff over and over. UV robots now. Cobot arms, everybody's making cobot arms, chasing what Rethink Robotics and what Universal Robot Teradyne has. And they're really arm wrestling for the same piece of the market. However, Universal has a strong lead and is widely used. So this will be interesting to watch. But again, not necessarily the most prudent thing for a company or an investor to look at. Of course, there are those that zagged. So companies like, again, Vicarious Surgical, which is a dual port surgical robot, very interesting. they received some early clearance, technology clearance by the FDA. I think the first time that's ever happened, because their technology, their solution is very, very promising. It could be very disruptive in the robotic surgical space. Dragonfly AeroVironment, U.S. North American built drones that serve different markets. Again, Kratos, Alster, again, because they don't just simply chase the autonomous vehicle market. Uvify, which is the world leader in swarm robotics for research and also for entertainment and advertising, and of course Universal Robot and Teradyne again. All of these companies are defining their respective markets. Thank you, and be well.
Based on the predictions of the International Data Group, by 2022, 93% of all data will be unstructured data, and 80% of the unstructured data is text. Hence, we understand the importance of building strong NLP models, namely natural language processing models. These models are not new to the scientific community, but today we can outperform traditional NLP techniques by quite a margin. This started a new revolution in the AI domain, and the first AI for text analysis tools are already created. Today, decision making in business is based on data. The challenge there is to find good quality data to make the best decisions. Until recently, we could process massively only structured data, that is, numbers. But what about all the hidden gems in the unstructured data? Imagine that you have a hotel and you want to know more about your guest's experience. How could you ever achieve that efficiently without considering their emails, their reviews, and voice under consideration? How can you understand if they feel positive or negative about your business? On top of that, wouldn't you like to know which aspects of your business are doing well and on which ones you should improve? I remember a hotel manager who could see low ratings of her hotel on TripAdvisor, but she could not comprehend the issue of those low ratings. She could read some of the 1,000 reviews online and still have no idea about the overall picture of the hotel, as she could not transform the unstructured data, the customer reviews, into structured ones and measure it. If she could manage to achieve that, she would efficiently monitor the hotel's performance on different aspects such as the food service or the food quality, the hotel's location, the room's cleanliness, etc. Imagine if she had a model on which she could feed all of the written reviews and receive as an outcome the total number of positive and negative reviews per aspect. This would help her gain a high-level view of her business and identify the particularly nasty elements. An AI model that deals with text could help her prioritize the hotel's needs and act more efficiently as a hotel manager. Assume now that you already have a few thousands of unstructured data. For example, you have product reviews or consumer complaints or emails or any other text from which you would like to extract insights. Now, this is a very challenging and time-consuming process if you execute it manually. The power of these models, of the NLP models, is that they are tireless, they are fast, they are accurate, and easy to use or even update when you want to. Their only weakness is that they cannot guess how would you like them to label your data. So I highly suggest you to have a clear idea of what you would like to achieve and how you should teach your model before even getting started with developing an NLP model. I have worked with small and big data, with models which are robust against noise and with models which are robust against big volumes of data. I have focused my efforts on high parameters tuning and algorithms benchmarking to discover the best solution for a specific task. I have also dived deep into creating datasets and test cases to understand how a model behaves in a particular spectrum, how to improve a model's performance, and discover corner cases where the model doesn't perform well. From my experience so far, I saw that there are mainly two types of engineers. The ones who try to improve performance by focusing on improving and automating only the code, and the ones who focus more on the data and try first to understand the model based on its input-output pairs and then modify it. Let's see one crucial reason why the first tactic, focusing on the code, is not very efficient. Imagine that you have a polymorphic tool with a bunch of settings according to the different usages. Now, if you make the settings before you even know the specific task that you want to do, then how can you know the proper settings? As these models are very complicated, this is impossible. Imagine only that an NLP model can consist of millions of parameters. It is not easy to optimize the performance without falling into the generalization overfitting trap. The cherry on top of these problems is that you have to explain the model's behavior to a technical or even to a non-technical audience, the customers. Models explainability is one of the biggest problems when it comes to AI models, as it is hard for consumers and stakeholders to trust a model that they do not even understand. It is hard for engineers to automate a model's correspondence to different cases if they do not know the full spectrum of these cases. Lastly, it is hard for data scientists to discover corner cases when these are rare and they are not even existing in the training data, but they might exist into the wild, into data that the model has never seen before. Regarding the customers, the best approach, in my opinion, is to work with them on specific business cases and involve them in their projects, so they will be able to understand more about the different topics, and by exposing them to different minor tasks like data labeling, they can understand better how these models are working. Additionally, you can write short business cases with easy to understand examples in order to give clients a high-level view of what an NLP model can do, how much time they can save using a model like that, and finally, how it can help them add value to their business. Lastly, creating blogs and small user stories, you can educate the customers and inspire the technical managers. These tasks require people with specialized knowledge and storytelling skills. But these tasks are essential for the growth of a business that works with AI models. Today, Python already has many libraries for different tasks, which are needed to build an NLP model. This is why Python is heavily used in machine learning today. Neural networks are huge models which demand prominent computational force for their training. This is why the system's design here is very important. To reduce the training time from days to hours, we use parallel and multi-GPUs computing. Also, different settings like stopping criteria should be modified such as we take the best results in the minimum time. Time is money here, as the training from scratch of a language model on a specific task can cost more than €30,000. So you have to design perfectly a system which does not break easily and it is scalable. You also have not many chances to try things out, as every trial is super expensive. Finding this combination of technical skills is complex. We have lack of talent in this area. And since technology is a fast-changing field, there is a lot of pressure and responsibility that falls on the engineer's shoulders. Luckily, some leading domain companies like Google have trained and free-sourced NLP pre-trained cutting-edge models like BERT, and someone can use them to reach faster and cheaper to a downstream trained on a particular task NLP model. So, actually, Google offers a pre-trained neural network that understands a language, and we can use it as a base to downstream train it on a specific task on a particular domain. In other words, I could take a model like BERT, which already understands English, and train it on customer reviews coming from a site like booking.com and teach it how to separate positive from negative comments. This is a downstream task called sentiment analysis. But there are many other tasks that an NLP model can conduct, like question answering, which is a job that we see in chatbots. So let's repeat that. A pre-trained on a specific language model like BERT can be found for free online on pages like Hugging Face. Now we can retrieve this free model like a library, and then we can further train it, or in other words, fine-tune it on a small dataset specific for the NLP task that we want to execute, like the question answering or the sentiment analysis task. Now let's see more details and tips for the data scientists who handle data which is used to train these models downstream. What should we be aware of? Which are the challenges in this training? When we want to train these NLP models, the first wall that we hit is to find suitable training datasets. Let's say that we want to train a sentiment analysis model that understands if a text contains positive or negative feedback for a business. Now, we will teach the model to read the comments based on their context by showing all the examples that we have in our training data to an algorithm. To collect these examples, we need annotators, or in other words, people who manually label comments. It is essential to involve business in this process because data labeling gives us a better understanding of the model and our data quality. It is also crucial to help companies to annotate data or label data properly in order to achieve high quality training datasets. After creating our training set, it is time to train the model and check out its performance. How we do that? We test it by providing examples which the model have never seen before, and we see if our model has learned from the training dataset. Now, if the output makes sense, meaning that a positive text is labeled from the model as positive feedback and respectively a negative comment is labeled by the model as negative comment, negative feedback, negative text, then our model has learned how to read the text properly. If not, if the output does not make sense in all or in some cases, then of course we need to investigate further these cases, change our training set accordingly and retrain the model. Different issues may result in having a wrong output. All these cases are based on the training dataset. Maybe our model misses information, so we need to add examples that provide this information in the training data. Perhaps we have provided some examples with the wrong label, so we need to remove these examples and retrain. Maybe we have not split our text correctly and it contains positive and negative feedback, so it is not clear for the model which labels to assign. Maybe we are biased about the label and our model is actually correct. For example, we see a 5-star review on booking.com and we expect that it will contain positive feedback. But in the comment, it's actually written a negative comment, like the only thing that I do not like in your hotel is that it is far away from the beach. But it has a 5-star review. Hence you understand why data scientists have to dig deep into the data in order to understand an AI model's behavior and discover necessary changes to steer its behavior in another direction. Another big problem with NLP models and their training data is that languages are very vast fields. They might hide many different meanings. There might be many synonyms in order to describe something. Some people use sarcasm in their comments. And someone can explain something very differently based on their education, work, language skills, and so on. Hence we understand that creating an excellent training data set which will describe the actual data quite well is super challenging, is almost impossible. The real data is an inhomogeneous data set with a wide variety and meanings that are changing based on the domain that they are used to. For example, in the domain of customer service, the word cheap could be used with a very negative meaning as the waiter is cheap. When he realized that I will not give him a tip, he became rude. And in some other domains, the word cheap can have a very positive meaning. Like for example in the food industry, we could have a comment like that. This restaurant is cheap, which is actually a positive thing. Knowing that text is difficult even for people to comprehend, but at the same time precious information is hidden in it, we do expectations management first in this area, and then we have a look at the big advantages of the NLP models to remember which are our alternatives and why we bother at the first place to solve all these big problems that are generated during their training. I will leave you with this. In data science, we make decisions based on our data. Data collection is not a big issue today. On the contrary, the volume and the velocity of big data force us today to use powerful AI models to process information faster and better by using brutal computational force and intelligent algorithms to achieve data transformation and knowledge extraction. Having this task automated by cutting-edge software is very impressive. It saves us a lot of time that we can actually use to understand these tools and then use them to process information massively. Information leads to knowledge, and we can use it to respond better and quicker to changes, understand our business, and make better business decisions. This is how technology and artificial intelligence can help us avoid overwhelming and at the same time learn from all this data and focus on how to take quicker, smarter decisions regarding big, complex problems. Thank you very much for watching.
Hey everyone, you are aware that the face of the global industry is one that is constantly changing. So 2021 was no exception to this rule. And we had some interesting manufacturing advancements taking place this year in 2021. However, we should differentiate that while in 2020, the global headlines were mostly dominated by topics such as the pandemic, closed sectors, reduced consumption, and shrinking production. In 2021, this year, we had headlines focusing more on the accelerated implementation of robots in manufacturing, of the global chip shortage, some interesting initiatives in the field of battery production, for example, and other industrial niches, and of course, the rapid progress and growth of industrial automation. Now, which were the key technology advancements in manufacturing this year? I'm going to focus on three small trends which I saw evolving this year and which I believe we should observe, keep an eye on, and they can evolve further in the coming years. Now, the first trend, which is emerging and I believe can be very interesting and implements a manufacturing innovation, are the microfactories. Um, Now, this year, according to the International Federation of Robotics, we had global robot density reach a new record high. Robots have a key role to play with any type of manufacturing innovation, basically, but especially with microfactories. Now, what is the concept of a microfactory? Um, is, for example, the assembly line, which has been here for decades, the most efficient way to assemble, for example, an electric vehicle. Well, this year, some startups started saying no. Another way, which is more efficient, is a microfactory. So, what is a microfactory? Well, basically, creating highly automated microfactories where, for example, electric vehicles can be assembled by multitasking robots who actually break the approach, which was pioneered from Henry Ford and used for most of the automakers globally for nearly a century. So nowadays, micro plants would produce tens of thousands of vehicles per year, and that's far fewer actually from what traditional auto plants produce. But traditional auto plants require far more workers and typically produce, of course, more. But the assembly line approach is very capital intensive, and you have to have high production in order to make any margin. While microfactories actually can eliminate some of the most expensive parts from uh, from the production in a given auto plant. Basically, the microfactories focus on assembling by multitasking robots combined, of course, with humans, and not so much on expensive capital intensive operations. It's still early on to discuss whether building microfactories actually is economically feasible and whether it can shape the face of the global auto industry. But I believe that the trend definitely has potential, and making more niche and more not so mass production via robots definitely can be economically viable. And I believe this is a trend all of us professionals in the fields of manufacturing, robotics, and etc., is one that is actually useful to keep an eye on. The second trend, which I have noticed this year and I believe will be interesting for the coming years, are the micro fulfillment centers. Now, can, for example, a small e-commerce company compete with a behemoth such as Amazon? Well, actually, companies developing micro fulfillment centers say yes. The micro fulfillment concept is one that is based around providing space to multiple tenants and deploying robots to run it, but it can also potentially involve companies taking space within larger warehouses that they don't own themselves. So a typical micro fulfillment center would involve robots and humans. It's scanning and controlling stations, basically running the whole micro fulfillment center. And the robotic solution, of course, is key, and it makes the micro fulfillment center differentiate. An integrated set of both hardware and software that can be implemented in the customer's own warehouses and automate the process of selecting, moving around, packing items, can be very efficient and as same as the microfactories, which significantly reduce first the investment and second the costs for running it. The micro fulfillment centers reduce the cost of fulfillment operations, sometimes by a margin of 75%. And both the micro factories and the micro fulfillment center don't remove humans from the chain altogether. They are just a solution which is less capital intensive and and more cost reducing. So I believe that those two trends combined together can really shape, especially the future of manufacturing startups and both large scale producers willing to experiment and conduct their operations in different matters. The third trend, which I'm going to discuss, is one which is specifically occurring this year, and it revolves around how companies and especially manufacturers resolve supply chain issues. Now, as all of you know, most businesses have faced some type of supply chain issue nowadays in 2021. But the key issue is actually how do we cope with these? Now, for example, companies which had deficit shipments of chips and other electric components have been using a couple of exotic approaches, but ones that do work and ones that do represent type of manufacturing innovation. For example, part of the companies do re-engineer their machines so that they need fewer chips or components which are currently in deficit. And this also includes rewriting software and firmware to support alternative types of chips. So it's a really large scale project. We saw also that some of the companies utilize other means, for example, implementing technology for liquid cooling of microchips, which allows the higher performance of devices even with fewer chips. And we've seen that producers which are more dependent, for example, on raw materials, do obtain cheaper and faster raw materials, for example, with the likes of aluminium by recycling household appliances as well as recycling multiple other raw materials. We know that recycling was not the most popular option when the global supply chains were running smoothly, but nowadays it's becoming something which is of interest to more and more companies. Now, we also saw that a lot of manufacturers do implement supply chain software and solutions that learn from multiple data points, which analyze deadlines, delivery, their quality, and they filter any type of traders and providers who delay delivery, who deliver poor quality products, as well as any illicit opportunities. And we've seen that such type of software solutions, they basically allow manufacturers to build a completely new supply chain. And a lot of the companies have utilized such options to basically introduce a completely new supply chain for Europe or for the US with local suppliers. And basically, this type of newly set up supply chain can keep their operations running. So these were three of the manufacturing innovations which I observed this year. I'm aware that manufacturing is a constantly evolving one, and that the innovations are occurring not only every month but on a daily basis. I believe that it's important to observe whether small scale production and fulfillment operations, as well as supply chain changes, how they can influence manufacturing. And I believe that will these trends deepen and evolve, or will they be just a temporary solution? We are yet to observe and find out. But one thing is certain: observing those trends is key for us to understand how we can move faster, better, and run our operations in the most smooth and profitable way. Thank you for your attention.